Good morning, my dear students. As I told you in the last class, in the organic chemistry complementary course for third semester, I will be engaging you 3 modules, 1 hour per week. Okay. We will start with the first module, that is module 1, organic chemistry, some basic concepts. Today we are not entering into the module, but I would like to give you a foundation in organic chemistry, because some people feel organic chemistry a little hard. So by going through some fundamental concepts in organic chemistry, you will get a good start. Okay, first of all, let us discuss about valency. In organic chemistry, we know that the key element is carbon. Valence of carbon is 4, it is tetravalent. It can come in single bonds, 4 single bonds around carbon. It can be a double bond and 2 single bonds, or 2 double bonds, or a triple bond and a single bond. The thing is that whenever you count, you should ensure that there are only 4 lines around a carbon generally. Okay. Nitrogen valence is 3, so it can come in this way. A double bond and a single bond, or a triple bond, means valence is 3. Oxygen valence is 2, it can come like this. In some organic molecules it can be like this. And hydrogen is univalent, and halogen X means fluorine, chlorine, bromine and iodine is monovalent. So this is a very valid point to be kept in mind while drawing structure, while writing organic reactions, mechanism, etc. Okay. Number 2. Next is classification. We know that organic compounds are many. Number of organic compounds is more than the number of inorganic compounds put together. That is amazing. We know that it is due to many properties, mainly because of the catenation property of carbon. Okay. In organic compounds, one class is what are called hydrocarbons. You know that? Compounds containing only carbon and hydrogen, right? They are classified in this way. First, into 2 types based on the shape or structure. It can be acyclic or open chain. It is also known as aliphatic compounds. And the second category is cyclic. So 2 types, cyclic or closed chain. This is again divided into 3 types based on whether saturated or unsaturated. Alkane, alkene and alkyne. Alkane contain only carbon-carbon single bond. It is also called saturated hydrocarbon. This contain double bond, alkene, and alkyne contain at least 1 triple bond. These 2 are together called unsaturated compounds. You might learn in some other modules that they undergo addition reactions and form saturated compound by breaking the pi bonds. Okay. Another point is that these are what are called homologous series. They constitute a series of compounds, a family of compounds, which are represented by a general formula. You know that. For alkane, CnH2n plus 2. Here it is 2n and here it's 2n minus 2. Examples, a simple example, ethane, ethene and ethyne. So it is this last 3 letters which make the difference in the name. Ane if it is alkene, Ene and Yn. Okay. On to the other side, in the cyclic compounds there are 2 categories. One is called alicyclic. This alicyclic is cyclic compound but similar to the properties, similar to aliphatic in properties. That's why we call alicyclic. So that can that may include like this into 3 types: cycloalkane, cycloalkene and cycloalkyne. Only thing is that they are cyclic, properties are similar to these. Whereas this aromatic, that is a very special category of organic compounds. Maybe the most important class of organic compounds is aromatic, which contain benzene as the classical example. Benzene and related compounds. That you will learn in detail in another module. Okay. Now, these are the 2 things. Now we go to the third fundamental idea, concept in organic chemistry, that is various functional groups present in organic compounds. See, apart from carbon and hydrogen, you know that some heteroatoms like nitrogen, oxygen, sulfur, halogen, etc. also appear in organic compounds. Then we call their functional compounds. So, apart from hydrocarbons, other organic compounds which also contain heteroatoms, they may contain different functional groups. You know what are functional groups? Let me note which are important functional groups. So this is the third point of discussion. Important functional groups. Just you may revise what you have learned in the +2 course. Some important ones which we are concerned with in this semester on this paper. Some important ones like, halogen compounds are there, or what we call halides. It can be alkyl or aryl halides. The functional group is X, right? Then alcohol, another one. Alcohol is containing the group OH. If it is connected to a benzene ring or aromatic ring, then we call a special name, that is phenol. Okay. Then let us consider aldehyde. Aldehyde is having the functionality CHO or C double bond OH. Then ketone. Ketone is having CO group. Here one hydrogen and one carbon comes, here both will be carbon. Then carboxylic acid, another important class of organic compound. Carboxylic acid, the functional group COOH, right? C double bond OH. And now this carboxylic acid has a lot of derivatives. By changing this OH group by various groups, like if it is COX, it is called acid halide. If it is NH2, it is called acidamide. If it is COR, it is called ester. If it is OCOOR, it is called anhydride, like that. Then we can note amines. Amine is, the functional group is NH2 containing nitrogen, and many more are there. I'm not going to that details, but you should remember that there are so many functional groups in organic compounds. Okay. Finally, let me tell you a few points about another important concept in organic chemistry, what is called isomerism. The knowledge of isomerism is very important in drawing organic structure of organic compounds. You know what is isomerism? The phenomena by which two different molecules possess same molecular formula. Molecules having same molecular formula but different structure. That is what is isomerism, and the compounds are called isomers. Isomerism is, you will learn all these in detail in different modules. I am only giving a brief idea which is required for further study. Isomerism is broadly divided into two types. You know that, you might have learned that. One is structural and the other is stereo. Structural isomerism and stereo isomerism, right? The difference is, in structural isomerism, the compounds differ in the connectivity, atom to atom connectivity or structural formula. Here the difference is in the spatial arrangement. Okay, in structural it is again of 3 or 4 types. One is chain isomerism, the other is position isomerism, and then it is functional isomerism, and then is metamerism, which is not very important in our discussion now. Anyway, stereoisomerism is first divided into 2 types. I'm not explaining it much because we will concentrate here for our purpose. Here it is conformational. You might remember the conformations, eclipsed and staggered conformations of ethane, by free rotation of carbon-carbon single bond, that is conformational isomerism, conformational, and this is configurational. There are some difference here. Configurational isomerism, which is of again two types. One is geometrical isomerism and other is optical isomerism. It's a big area to be discussed in detail that you will do in other modules by other teachers. I will concentrate here, which is required for our purpose. See, in structural isomerism, what is chain isomerism? Let me put examples for chain isomerism. Let me write a molecular formula C4H10. This is CnH2n plus 2, that is the formula of saturated compound, so it can be butane, but this can be written in two ways, either in straight line, okay, or branched. These are the two ways. So these differ in chain, this straight chain and this is branched chain. So we get two different molecules in the same formula. And you will fill with hydrogen, that is quite easy. If there is one bond, then I have told you at the beginning, the key of organic chemistry is the tetravalency of carbon. Carbon can have 4 lines around it. So one here, so remaining 3 will be hydrogen. So fill with hydrogen, just do that, it will fit with the formula automatically. There are 2 lines here. So here it will be CH2, and end will be always CH3. Here it is CH3, this will be H only because there are 3 lines, so one more, it's 4. And this is CH3, CH2. So there are 2 chain isomers for this formula. I am giving a question. Write the chain isomers for the formula C5H12. Okay, you do it. That's a question to you. Write various chain isomers for the formula C5H12. So what you do? First you draw 5 carbons in a row, a straight chain. Then you go for branches. You will end up with 3 isomers. You will see that. Okay. And then position isomerism is quite simple. The difference is here in the position of the functional group. For example, let me take the molecular formula C3H8O. And let me take this oxygen present, so it can be alcohol. For example, suppose I am writing CH3, CH2, CH2OH. What is this compound called? This is propan 1-ol. This is position 1. Right? Propan 1-ol. I am not going to the details of IUPAC nomenclature in this session because that's a little wide area. You will discuss in different chapters the naming of compounds of different functional groups. So this is propan 1-ol. We can change the position into this one. Then it is CH3CHOH, CH3. This is propan 2-ol. These are position isomers. So in position isomerism, compounds differ in the position of the functional group, or it can be position of double bond or triple bond as well. Now finally, let me tell you about functional isomerism. What is the difference here? 2 compounds have different functional group but same molecular formula. Let me take one example. C3H8O. The same thing which I have written earlier. This, see how you guess out structures. Looking at the formula, it's like this. Adhyam, you look here, C3H8. Now, H8 എന്ന് പറയുമ്പോൾ this is 2 CnH2n plus 2 formula. Saturated. There is no carbon-carbon double bond or triple bond. Then oxygen. Now, saturated functional group can be either alcohol or OH, that's double bond, or it can be either also. So I am writing 2 possible structures, CH3, CH2, CH2OH, okay, or it can be CH3O, CH2, CH3. You can check with the formula, it will match, it will be in agreement. So these 2 are called functional isomers. They differ in the functional group having the same molecular formula. Okay. It is good to think about more isomers for the same formula. It's an interesting job. I'm taking another example. Okay. It's interesting. C3H6O. Okay. you are asked to draw all possible isomers from this formula. So what you do, how you think, in what way you think. Oxygen ഉണ്ട് അതുകൊണ്ട് എന്തൊക്കെ ഫങ്ഷൻ ഗ്രൂപ്പ്സോ ആവാം, OH ആവാം, ആൽക്കഹോൾ ആവാം, ഈതർ ആവാം. ഈതർ എന്ന് പറഞ്ഞാൽ ഓക്സിജന്റെ സൈഡിൽ കാർബൺസ് കണക്ട് ചെയ്തിട്ടുള്ള ആൽക്കൈൽ ഗ്രൂപ്പ്സ് വരും. അല്ലെങ്കിൽ ആൽഡിഹൈഡ് ആവാം, കീറ്റോൺ ആവാം. 4 സാധ്യതയുണ്ട്. കാരണം ഇവിടെ C3H6 ആണ്, അൺസാച്ചുറേറ്റഡ് ആണ്. ഒരു ഡബിൾ ബോണ്ട് വരാം. ആ ഡബിൾ ബോണ്ട് വേണമെങ്കിൽ ഫംഗ്ഷൻ ഗ്രൂപ്പിൽ വരാം, C double bond O അങ്ങനെ വരാം. So you can draw many isomers here. Let me write, for example, CH3, CH2, CHO. Okay, what is this? This is propanol. 3 carbons of propanol aldehyde. It can be a ketone. Ketone ആയിട്ട് എഴുതുമ്പോൾ എങ്ങനെ വരും? CO ഇടയിൽ കൊടുക്കണം. ഇതാണ് ketone. അല്ലേ? CH3CO, CH3 ketone. These two are functional isomers. Can you think of some other functional isomers for the same formula? Yes, it is possible. That is, you can keep an alcohol group. All structures a beginner should do like this. First you draw the carbon skeleton and then fill the required functional groups and finally fill hydrogen. That's the way you draw structure in initial stage. Once you are sure, you can draw just like that. അപ്പോൾ ഇവിടെ ആൽക്കഹോൾ നമ്മൾ ഗ്രൂപ്പ് കൊടുക്കുകയാണെങ്കിൽ നമ്മളിവിടെ OH കൊടുക്കും. ഓക്കെ, ഇനി ബാക്കി ഹൈഡ്രജൻ ഫിൽ ചെയ്യണം. പക്ഷേ യു ഷുഡ് ഫോളോ ദിസ് ഫോർമുല. ഹൈഡ്രജൻ ആറിൽ കൂടാൻ പാടില്ല, അഥവാ അൺസാച്ചുറേറ്റഡ് ആണ്, ഒരു ഡബിൾ ബോണ്ട് വേണം. അപ്പൊ ഡബിൾ ബോണ്ട് നമുക്ക് ഇവിടെ കൊടുക്കാം, ഇവിടെ കൊടുത്തു. ബാക്കി ഹൈഡ്രജൻ ഫിൽ ചെയ്യാം. 2 ബോണ്ട്, അപ്പൊ പിന്നെ 2 ഹൈഡ്രജൻ അല്ലെ, ആകെ 4. 2, 3, അപ്പൊ ഒരു ഹൈഡ്രജൻ, 2 ബാക്കി 2 ഹൈഡ്രജൻ. ചെക്ക് ചെയ്യാം എത്ര ഹൈഡ്രജൻ ഉണ്ട്. 2, 3, 5, 6. കറക്റ്റ് ആണ്. It will automatically fit. It's interesting. You just keep track of the unsaturation. The rest will automatically come. So this is also another functional isomer. You can also change the position of OH. You can change the position of double bond. You can also try with either functionality. Many are possible. So this is an interesting area of organic chemistry, trying all possible structures and naming it. Actually, that is a question, a work I am giving to you. So in this class, these are the 4 basic concepts required in organic chemistry to go with. I'm sure you will recollect all these from your +2 knowledge. What all you have to do is you practice drawing structures. As I've told you, we have no provision of discussing nomenclature in this module. That you try yourself. I'm giving a question for practice. In the next class, when I come, you should have answers for this question. The question is this. You may write the question. I have given already one question. This is the second question. Question is like this. You may write down. Write all possible isomers for the following molecular formula. Write all possible isomers for the following molecular formula. Then A, C6H12, B, C6H12O. And then you write, also give IUPAC name of each. Right? So this is a small question, but giving a big answer. It's interesting to try on structures for this formula. I'm just giving some hints. For example, this one, C6H12. How you write structures, all possible isomers. When you write all possible isomers, think of the classification of isomerism. It can be structural, and which can be chain, position, functional, and it can be stereo also. Even though we did not discuss it here, you might have some basic knowledge of stereoisomerism, like geometrical isomerism, or what is called cis-trans isomerism, optical isomerism. You can try all of them, and also conformational isomerism. So, for example, when you go to this one, what you do is, there are 6. First, you check the degree of unsaturation. Means, ഇവിടെ ഫോർമുല ചെക്ക് ചെയ്യുക. CnH2n ഫോർമുല. അപ്പോൾ ഇതെന്താണ്? അൺസാച്ചുറേറ്റഡ് ആണ്. അഥവാ ഒരു ഡബിൾ ബോണ്ട് നിർബന്ധമായിട്ടും വേണം. റിമെമ്പർ, ഒരു ഡബിൾ ബോണ്ടിന് പകരം ഒരു റിംഗ് വന്നാലും അൺസാച്ചുറേറ്റഡ് ആണ്. നേരത്തെ നമ്മൾ കണ്ട സൈക്ലോ ആൽക്കെയിൻ, അതിന്റെ ഫോർമുലയും ആൽക്കീന്റെ ഫോർമുലയും സെയിം ആണ്. കാരണം ഒരു റിംഗ് ഫോം ചെയ്യുമ്പോൾ രണ്ട് എൻഡിലെ കാർബൺ കണക്ട് ചെയ്യാണ്. അപ്പോൾ രണ്ട് ഹൈഡ്രജനെ റിമൂവ് ചെയ്യുമ്പോഴാണ് വാലൻസി സാറ്റിസ്ഫൈഡ് ആവുക. ഓക്കെ, സോ ഹിയർ ഐ എം ജസ്റ്റ് ഗിവിംഗ് സം ഹിന്റ്സ്. യു മൈറ്റ് ഫസ്റ്റ് ട്രൈ ഓൾവേസ് വിത്ത് ദ സ്ട്രേറ്റ് ചെയിൻ അല്ലെ. ആദ്യം നമ്മളിങ്ങനെ 6 കാർബൺ സ്ട്രേറ്റ് ചെയിൻ വച്ചിട്ട് ഹൈഡ്രജൻ ഫിൽ ചെയ്യണം. അതിന് മുമ്പ് ഡബിൾ ബോണ്ട് ഉണ്ട്. എവിടെ ഡബിൾ ബോണ്ട് കൊടുക്കും? വി ക്യാൻ ഗിവ് ഇറ്റ് ഫസ്റ്റ് ഹിയർ. അപ്പോ ബാക്കി ഹൈഡ്രജൻ ഫിൽ ചെയ്യണം. ഇവിടെ എത്ര ഹൈഡ്രജനാ? 2 വന്നാൽ ബാക്കി 2. ഇവിടെ 1 2 അല്ലെ. CH2 CH2 and CH3 and then name it. What is the name? 6 carbon hex position 1. This is position 1 for double bond. So hex 1A. Formerly it was called 1-hexene. The latest IUPAC's recommendation says you should name it hex 1A. Okay. ഇനി എന്ത് ചെയ്യാം? നമുക്ക് അടുത്ത ഐസോമർ വരയ്ക്കാൻ ഒന്നായി. രണ്ടാമത്തത് പൊസിഷൻ മാറ്റിയ ഡബിൾ ബോണ്ടിനെ ഇങ്ങോട്ട് കൊടുത്താൽ ഹെക്സ് 2 ഇൻ, ഇങ്ങോട്ട് കൊടുത്താൽ ഹെക്സ് 3 ഇൻ, ഇങ്ങോട്ട് കൊടുത്താൽ ഹെക്സ് 4 ഇൻ. നോ, അവ നമ്പറിങ് നമ്മൾ വിടുന്നാവും. ഇറ്റ് വിൽ റിപ്പീറ്റ്. അപ്പൊ ഇവിടെ 3 കിട്ടി. ഇനി നാലാമത്തത് നമ്മൾ എന്ത് ചെയ്യും? കാർബൺ ചെയിനെ മാറ്റി ചെയിൻ ഐസോമേഴ്സ് ട്രൈ ചെയ്യാം. ഇത് പൊസിഷൻ ഐസോമേഴ്സ്. അപ്പൊ നമ്മൾ 5 കാർബൺ നേരെ വരച്ചിട്ട് 6ാമത്തെ കാർബൺ ബ്രാഞ്ച് ആയിട്ട് കൊടുക്കുക. എവിടെ കൊടുക്കാം? യു ക്യാൻ ഗിവ് ഇറ്റ് ഹിയർ ഓർ ഇറ്റ് ബി ഹിയർ. ഇവിടെ എവിടെ സെയിം ആയിരിക്കും. എന്നിട്ട് ഡബിൾ ബോണ്ട് കൊടുക്കുക. ഡബിൾ ബോണ്ട് എവിടെ കൊടുക്കാം? യു ക്യാൻ ഗിവ് അറ്റ് ദി എൻഡ് ആൻഡ് ദെൻ ഫിൽ വിത്ത് ഹൈഡ്രജൻ. യു ക്യാൻ ഗിവിംഗ് ഹിയർ ഈസ് സെയിം. അല്ലെങ്കിൽ ഇവിടെ കൊടുക്കാം, ഇവിടെ കൊടുക്കാം, ഇവിടെ കൊടുക്കാം. ഇങ്ങനെ 4 രീതിയിൽ ഡബിൾ ബോണ്ട് കൊടുത്തിട്ട് നമുക്ക് സ്ട്രക്ചർ ആക്കാം. Right? See, it is increasing. Can you guess how many isomers are possible for C6H student? Can you guess? It will increase like anything. The number will go on increasing when you go to writing the structure. Then you will make it 4 carbons and then 2 branches. 2 branches can be like on the same carbon and giving double bond, or it can be on different carbons. Like that you will go. Then you can try ring structures. I have told you 6 carbon, so like this. What is this? Cyclohexane. 6 carbon, cyclohexane. What is the formula? What is the molecular formula? It is C6H12. CH2, 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 CH2. This is also unsaturated. So point is that to have a double bond is equivalent to have a ring. Equally unsaturated. Okay. ഇനി നമുക്ക് റിംഗ് സ്ട്രക്ചർ കുറച്ചുകൂടെ സ്മോളർ റിംഗ്സിലേക്ക് പോകാം. Drawing more isomers. When you draw this, you think of the conformational isomers. This is having chair and boat form, you know. That's again isomers. When you go for smaller ring, നമുക്ക് 5 കാർബൺ വെച്ചിട്ട് റിംഗ് വരക്കാം. ഇനി ബാക്കി ഒരു കാർബൺ ഉണ്ടല്ലോ, അത് നമുക്ക് ഇവിടെ കൊടുക്കാം CH3 ആയിട്ട്. So what is this? This is called methyl cyclobutane. Correct? Then you can go for still smaller ring like 4 cyclobutane വരക്കാം. This is cyclobutane. ഇനി 2 കാർബൺ ബാക്കിയുണ്ടല്ലോ. റിംഗ് വന്നാൽ ഇനി ഡബിൾ ബോണ്ട് കൊടുക്കരുത്. റിംഗ് വന്നാൽ ഡബിൾ ബോണ്ടിന് പകരമായി 2 കാർബൺ നമുക്ക് എങ്ങനെ കൊടുക്കാം? You can give 1 carbon here or both carbon here, one way, or you can give both carbon like this, like an ethyl group. You can give 1 carbon here and 1 here, or 1 here and 1 here. When you draw 2 carbons, suppose here at the adjacent position, it can be drawn like this actually. See, CH3, CH3, HH, right? This is what? 1,2-dimethyl cyclobutane. This is one isomer. Actually, this has got cis-trans isomerism. When both methyl is above the plane of the ring, it is cis. When one above and one below, we can draw in another way like this. This is trans. That is the geometrical isomerism in ring compounds. Like that, so many possibilities. Okay, so that's what I said. What you do is you draw all possible structures. This is a work for you, is an assignment. Actually, this is the weekly assignment. In the weekend, you do this, right? You answer this question. When you go to the next one, it is still more interesting. Why? ഇവിടെ ഓക്സിജൻ കൂടെ വന്നു. അത് മാത്രമല്ല, ഇത് അൺസാച്ചുറേറ്റഡ് ആണ്. അപ്പൊ എന്തൊക്കെ പോസിബിലിറ്റി ഉണ്ട്? നിങ്ങൾക്ക് അതിന്റെ ഓപ്പൺ ചെയിൻ സ്ട്രക്ചർ വരക്കുമ്പോൾ ആദ്യം നിങ്ങൾ ഓപ്പൺ ചെയിൻ വരക്കുക, മീൻസ് അസൈക്ലിക്. അതിൽ നിങ്ങൾക്ക് ഈ ഇതിൽ അൺസാച്ചുറേഷൻ ഉണ്ട് അഥവാ ഡബിൾ ബോണ്ട് ഉണ്ട്. ഈ ഡബിൾ ബോണ്ട് നിങ്ങൾക്ക് കാർബണിന്റെയും കാർബണിന്റെ ഇടയിൽ കൊടുക്കാം. അല്ലെങ്കിൽ ഈ ഓക്സിജൻ ഒരു ഫംഗ്ഷൻ ഗ്രൂപ്പ് ആയിട്ട് എടുക്കുകയാണെങ്കിൽ എന്തൊക്കെ വരാം? നേരത്തെ പറഞ്ഞു 4 പോസിബിലിറ്റി. ആൽക്കഹോൾ, പക്ഷെ അതിൽ ഡബിൾ ബോണ്ട് പറ്റില്ല, അപ്പൊ കാർബണിൽ ഡബിൾ ബോണ്ട് കൊടുക്കുക. പിന്നെ ഈതർ ആവാം. ആൽഡിഹൈഡ് കീറ്റോൺ ആണെങ്കിലോ ഡബിൾ ബോണ്ട് ആ ഫംഗ്ഷൻ ഗ്രൂപ്പിൽ തന്നെ വന്നു. പിന്നെ നമ്മൾ ഡബിൾ ബോണ്ട് ഇവിടെ കൊടുക്കാൻ പാടില്ല, അല്ലെങ്കിൽ ഫോർമുല തെറ്റിപ്പോകും. Okay, now you can fill with hydrogen like that. You can try acyclic, you can try cyclic. In that also you can keep this oxygen in different functional form like ether, alcohol, aldehyde, etc. and ketone, etc. So you get more number of structures. So I repeat that the work, the assignment here is to draw all possible isomers, whether structural or stereo, of all these compounds and try to give IUPAC's name of each, right? So that's all in this session, giving a foundation in organic chemistry. You prepare well. I will come after 2 chemistry hours, means we are 3 teachers, we will come in rotation. So till then